Let's get started with Chapter 2, Section 4. Question number 1 asks us to graph the linear function, give the domain and range, and decide whether it is a constant function. To graph a linear function, we know that the graph is going to be a line. All you need are 2 points. You can get those 2 points by making a table. You can get those 2 points by using the slope and y-intercepts. And in this example, I'm going to use a table to find those 2 points. You're going to set up a table x and f of x. And f of x is actually the same thing as y, just another way of writing it. So we're going to plug in a value for perhaps x is equal to 0. If x is equal to 0 and you plug that into the function, you get 0 minus 9, which is negative 9. And let's plug in another number, let's say 1. Plug in 1. 1 minus 9 gives you a negative 8. You plot those 2 points on the graph that I have here. Let's enlarge it a little bit. You locate the first point, 0, negative 9, which is about right here, and then you locate the point 1, negative 8. Those are just 2 points, and with a ruler, you want to draw the line through those 2 points. Now, I'm not using a ruler, just kind of trying to do it best I can. But that is the sketch of the graph. Let's look at the choices that they give us on the homework. Which one of the choices looks most like the graph that we sketched? For my example, it looks like choice C. Fantastic. Okay, now we want to talk about the domain. When you're looking at a linear function to determine the domain and range, you want to look at how far to the left and how far to the right the graph is going to go. Or also think about all the possible numbers that you can plug into the function. This graph is going to continue to go down and down and down, continuing to the left on the x-axis, where x is going to go to negative infinity, and it's going to continue to go to the right. So when we think about domain, you want to think about the possible values you can plug into the function, and you also want to think about how far to the left and how far to the right the graph is going to go. And this graph is going to continue forever to the left and forever to the right, and forever to the left is negative infinity, and forever to the right is positive infinity. So that is our domain. Choice C for me. Check it. Continue. The range. When we talk about the range, we want to determine how low and how high the graph goes. This graph is going to go forever down, down, down on the y-axis, and it's going to go forever up. So when we talk about the range, we want to go from low to high. The lowest that this graph goes is negative infinity. It's going to keep going down and down and down, and the highest it goes is positive infinity. So our range is negative infinity to positive infinity. And then the last part of this question is asked, is the function a constant function? A constant function does not go up or down. It stays at the same height. This is not a constant function because the graph is increasing. So the answer to this question is no. The only way you can have a constant function is if the graph looks like a flat line, has the same y value no matter what the x value is. Moving on to number 2. Similar type of question. Graph the linear function, give the domain and range, and decide whether it is a constant function. It is a linear function, so we can graph this by finding 2 points and sketching those 2 points. But what I'd like to do with this one first is to solve this equation for y. That makes it easier when you plug in x values to get y values. So if you take this equation, I'm going to add 3x to both sides of the equal sign. And my new equation is y equals 3x plus 0, or simply y is equal to 3x. is make a table of values for x and y. And again, you only need to plot 2 points here and use a ruler. For example, if x is 0, plug in 0. Y is equal to 3 times 0, which is 0. And when x is 1, y is equal to 3 times 1, which is 3. So we're going to plot those 2 points on the graph. Oops. Make it a little bit bigger. I plot a point at 0, 0, and a point at 1, 3. Connect those with a straight line, ruler if you have it. Just kind of quick sketch here. And that is the first part, to graph the linear function. I solved for y and made a table of values, plotting at least 2 points. When you plug that in, or actually check your choices, it looks like choice D for me. The domain, when we talk about the domain, it's all the values from the left to the right. The domain is, I'm going to use D for domain. We think about left to right. How far to the left is this graph going to go? It's going to keep going forever and ever and ever to the left. So the domain is negative infinity, and it's going to keep going forever and ever to the right. You can plug all these different x values in, from negative infinity to positive infinity for the domain. And then for our range, we want to look at low to high. How low does this graph go, and how high does this graph go? This graph is going to continue to go down and down and down, and it's going to continue to go up and up and up. So it goes down from negative infinity all the way up to positive infinity. In this case, the domain in the range is negative infinity to positive infinity. Check your answer for domain and check your answer for the range. And then the last question is the function a constant function? It's only a constant function if the graph is horizontal, a flat line. This is not a flat line, so the answer to that question is no. If you look at the choices, choice A, if that was our graph, that is a constant function. Moving on to number 3. Here we're going to graph the function and give the domain and the range. We're going to use the graphing tool to graph the line. Before I start using the tool, I do want to make a table of values and find at least 2 points. And make your x and f of x. And remember, f of x is just the same thing as your y. Plug in 0. When you plug in 0, there's no place to put the 0. So the output here is negative 2. If you plug in 1, again, there's no place to put the 1, so the only thing, no matter what the x value is, the y value is going to be negative 2. So when we plot that by hand, it's going to look like 0, negative 2, 1, negative 2, and you're going to draw a nice little horizontal line through those. Using the graphing tool, you're going to select the line tool option, click on that one time, plot the first point, which was, let's scoot it over a little bit, the first point was 0, negative 2, and my second point was 1, negative 2. Scoot it over a little bit so you can see I plotted. I'll do that one more time. First select the line tool one time, put the point at 0, 2, and then the next point at 1, negative 2. And then save that. And let's check our answer. Well done. Now we want to talk about the domain and the range. Again, to find the domain, we want to look at the values, how far to the left the graph goes and how far to the right the graph goes. So our domain, we use D for domain, is left to right. This goes forever to the left to negative infinity and goes forever to the right to positive infinity. The graph goes forever in both directions. You can plug everything into this function. using the palette here, using the parentheses, it's a negative infinity to infinity. Oops, to infinity. Check your answer. Fantastic. Now the range. The range, when you're looking at the graph like this, is how low the graph goes and how high the graph goes. The lowest that this graph goes on the y-axis is -2. The highest that this graph goes is +2. So it's no longer a collection of values, it's a single value for the range. And we're going to put that value in squiggly brackets. Moving on to number 4. Number 4, we want to graph the equation, which is y equals -7. And we can do that by making a table, plotting points, and sketching the line. Now this equation only has a y in it, so because I've practiced this before, I know the graph is only going to go through the y-axis. If you wanted to make a table of values, if you choose 0 for x, notice there's no place to put an x. So even if x is 0, the y is automatically going to be -7. You could even try another value, such as x is equal to 1. And again, there's no place to put a 1 into the equation, so y is automatically -7. What this means is that no matter what the x value is, on this line, the y is always -7. What this graph looks like when we sketch it is that we are going to plot a point at 0, -7, and plot a point at 1, -7. This line only has a y in it, so it's only going to cross through the y-axis. It's not going to cross through the x-axis, so it has to be a flat line that goes through -7. When we check our answer, that looks like choice C, and we are done. Let's see about doing one more in this video. Question number 5. Match the equation below with the sketch that most closely resembles this graph. Now this equation only has an x in it, so the graph is only going to go through the x-axis. You can make a table of values if you want, but the only thing that you can plug in is x is equal to 7. There's no y in the equation. Y could be anything. For example, y could be 0. Y could be 1. No matter what y is, the x is always going to be 7. So you can plug that into your, plot those points. X is equal to 7, and the y could be anything. So it's going to be a vertical line. Whenever you have an equation that only has an x in it, it's going to be a vertical line through that number. It doesn't have a y in it. This graph is not going to cross through the y-axis. So let's choose x equals 7 as our answer.